Hello everyone, this is Mr. Dickon here, and today we are going to take our next step on our journey towards enlightenment for rational functions. Before we do so, by the way, we're going to be solving equations that look a little something like this and this. Scary, I know. Before we do so, we're going to look at a pretty straightforward example just dealing with fractions, because after all, rational functions and rational expressions are just fractions. The word rational means fraction, ratio, fraction. Right here, I have an equation that I completely made up. I have no idea if this is going to work out to be a clean, pretty number or not. Here we have 3/4 plus 2/7 minus x halves equals 11/14. Right now, I'm not allowed to add or subtract any of this stuff on the left-hand side because my denominators are not the same. So in order to remedy this, what we can do is a process called clearing fractions. And essentially what that means is we're going to find the common denominator, and we're going to multiply every single term by the least common denominator, and things are going to cancel out kind of nicely. Because after all, I can do whatever I want to the left-hand side of this equal sign, as long as I do the exact same thing to the right-hand side. So for whatever reason, if I wanted to multiply everything on the left by 8, I can, as long as I multiply everything on the right by 8. So what I need to do first is find the least common denominator, or the LCD. I need to figure out, what does 4 go into, that 7 also goes into, that 2 goes into, that 14 also goes into? Well, one way to think of this is if I look in factored form, 4 is the same as saying 2 times 2. 7, well, that's just 7. I can't really factor that. It's prime. Same goes for 2. And then 14 is the same as 7 times 2. So each denominator kind of has its own requirements. First denominator says that my least common denominator has to have at least 2 2's. It can have other stuff, but as long as it has 2 times 2, we're good. My second denominator says I have to at least have a 7 in there. Well, I don't currently have a 7. My next denominator says I have to at least have a 2. Check, already got it. And this guy over here says I need to have at least a 7, good, and a 2, good. So my least common denominator, and some of you are probably able to do this mentally, is going to be 2 times 2, which is 4 times 7, that's 28. So what I'm going to do is I'm going to multiply everything in this equation by 28. So let me rewrite the equation. 3/4 plus 2/7 minus x halves equals 11/14. And essentially what I'm doing is I'm multiplying everything on the left by 28 and everything on the right by 28. So if I do that, I'm multiplying technically the numerators here. So everything's going to get multiplied by 28. Now, assuming we did this correctly, every single one of these pieces should cancel out with the denominator and reduce a bit. So 28 over 4, that reduces down to 7. 28 over 7, that reduces down to 4. Next, we have 28 over 2, that reduces down to 14. And on the other side of the equal sign, 28 over 14, that'll reduce down to 2. So I've gone from one step here where I have a rational function, a rational equation with denominators, to my next line down, I have none of that. So now we can solve. We have 7 times 3 is 21, plus 8 minus 14x equals 22. We'll combine our like terms. 29 minus 14x equals 22. We go to solve. Negative 14x, moving that 29 over. Let me scooch the camera down a bit. Move that 29 over, so we'll get negative 7. Therefore, x equals 1/2. And from here, we can plug it back into the original and check. So let's do the same thing now with a scarier looking function. Here I've got 1 equals 1 over x squared plus 2x plus x minus 1 all over x. First thing I'm noticing is this does not have a denominator, so I'm going to put a 1 underneath it. And then I'm going to take a second to write everything in factored form. So we have 1 over 1 equals 1 over x squared plus 2x. That's got a GCF here of x. So we have x plus 2. Plus x minus 1 all over x, and now we're in factored form. So my least common denominator has to kind of combine the best of all worlds here. A 1 is kind of a cop-out, don't really need to do much here. I need to have at least an x and an x plus 2, and I need to at least have an x. So to satisfy everything, we'd have an x and an x plus 2. So I'm going to multiply every single numerator by x and x plus 2. Remember, whatever I do to one side, I have to do to the other in order to maintain equality. So for this first piece here, nothing cancels with the denominator, so I'm left with x times x plus 2. Equals, well, the x's will cancel, the x plus 2's will cancel, and I'm just left with 1, so that's kind of nice. And then over here I have the x's cancel each other out, and I'm left with x minus 1. So now from this step I have no more denominators, and it's just a plain old quadratic to solve. So I'll distribute the x into my parentheses here. Combining like terms, I see a 1 and a minus 1, those knock each other out, so I'll get x. Anytime we see an x squared and we're trying to solve, if there's also an x, we'd like to have an equals 0 on the other side. So that means this x has to scooch. So we're going to have x squared plus x equals 0. To solve, we'll factor out a GCF. I have x times the quantity x plus 1 equals 0. Therefore, x equals 0 and x equals negative 1. Now, before I confirm these, I have to make sure that I'm not breaking any math rules, because if we think back to excluded values, I might have accidentally divided by 0 if I plugged in one of these two numbers. Let's take a look here. I'm saying x is 0 and x is negative 1. Those were my two answers. And I'm not allowed to plug in anything that would give me a 0 in the denominator, because if I divide by 0, the universe implodes in on itself, and everything you've ever known or loved will then cease to exist. So let's see here. 0 plus 0, that's going to be, all right, so 0 doesn't work. If I plugged in negative 1, we're good here. Negative 1 squared is 1, plus 2 times negative 1 is negative 2, so negative 1 will work. All right, so 0 is off limits. Negative 1 is good to go. All right, sorry for that brief little intermission. Our last and final example will be the following. 1 plus x squared minus 5x minus 24 all over 3x equals x minus 6 all over 3x as well. Just like before, I'm seeing this plain old 1. It doesn't have a denominator, so I'm going to give it a denominator. I'm allowed to throw a 1 underneath anything. Dividing by 1 doesn't change anything. Also, just in looking at this, my denominators here are 3x and 3x, so I can already kind of assume my least common denominator is going to be a 3x. So that makes my job a little bit easier here. Let's see, what else do we have? Oh, excluded values. Numbers that I cannot plug in because I might get a 0 in the bottom, and I can't divide by 0, because if you divide by 0, the universe will implode in on itself, and everything you've ever known or loved will then cease to exist. So 3 times what gives me 0? That would be 0. So 0 is off limits. So just like before, we are going to multiply every single numerator by my least common denominator. Now, right here, some of you might be noticing, well, why aren't we factoring this right now? The x minus 8 and x minus 3. We could. But typically, you only want to do that with hopes of cancellations. And right now, nothing's going to cancel out with a 3x. If we saw like an x plus 3 down here, then absolutely that might help us. But for right now, I'm kind of looking ahead, and this wouldn't factor out of the top, so I'm not even going to bother factoring that out. All right, so let's multiply every single numerator by my least common denominator, which is 3x. I'm going to have to be careful here because I have to distribute onto everything there. Same here. So we'll have 3x times x minus 6. So when I do this, 3x does not reduce with the bottom. Okay, so that's just 3x times 1. Awesome. 3x, ooh, that actually does cancel out, so no need to distribute. So I'll have x squared minus 5x minus 24 equals, The 3 cancels, the x cancels, so the whole 3x piece cancels. X minus 6. So essentially, these two pieces are the same. The only thing that really changed was turning that 1 into a 3x. And now I'm able to write this without any denominators. So nothing too challenging here. I've got some like terms right here. I'm going to go ahead and combine those. And then after that, we typically like these to be equal to 0, so these guys are going to have to move over. So let's combine those like terms. We've got x squared minus 2x minus 24. 3 plus negative 5 is negative 2 equals x minus 6. And then we'll have to move the x over, so we'll subtract that from each side. Ooh, a little smudge here. The joys of being a lefty. We'll have to add 6 to each side, so those will cancel, those will cancel. So this whole thing is going to be equal to 0. Yeah, I'm making a little video. Miss Lavin's in the house, everybody. So we've got x squared minus 3x. Let's see, negative 24 plus 6. Negative 24 plus 6 is negative 18. So now I have x squared minus 3x minus 18 equals 0. And I need to solve. So we'll solve by factoring. There is no GCF. Instead, I just need two numbers that would multiply to negative 18 but add up to a negative 3. So I'll start them off with an x. Let's see, two numbers that multiply to negative 18 add up to negative 3. It's either 1 and 18, 2 and 9, or 3 and 6. And it appears like 3 and 6 is probably going to be my winning combo. So we'll have x minus 6 and x plus 3. If you have them in the opposite order, that is totally fine. Moving forward to solve, I would get x equals 6 and x equals negative 3. And let's just make sure neither of those are our excluded values. Well, we already found out the only excluded value is 0, so we're good. Those are our two solutions.